Good afternoon, students. Now we'll perform a practical number 12, that is test the functionality of T and D flip-flop. As we studied in our syllabus, that is D flip-flop is nothing but SR flip-flop. We have connected just one inverter there, and we constructed a delay flip-flop, that is D flip-flop, and we have seen a T flip-flop, that is toggle flip-flop. Means we have connected two inputs of JK flip-flop, J and K, and we have constructed T flip-flop. So basically whenever we need a delay in our application, we need a delay in switching, we'll use a D flip-flop, and toggle flip-flop is used whenever we require fast switching. So here again we are using IC 7476 for constructing the our flip-flops. Here you can see the diagram, internal diagram provided with IC, that is D flip-flop using 7476. Now we'll do the connection as per our diagram, in our digital board. So in blue socket a 7476 IC is connected. As previously told, the upper section is empty, so we are not using first 4 pins because they are empty, and we are using lower section, that is we are using 8 pins from left side and 8 pins from right side, as you can see on a board. So pin number 1 is we are considering at P3, and pin number 8 is considering at P10. Likewise pin number 9 is considering at P11, and P18 we are considering pin number 16. Also you can see on breadboard we have connected 7404 IC because we are constructing D flip-flop, and for that we have to connect a inverter between J and K input. So we have placed a 7404 IC on breadboard. Now we'll see a connection. First we are giving J input to pin number 4 and we are providing D input to it. So we have taken the wire from pin number 4 and it is given to input section, that is our J input. Then we'll make a connection for inverter, that is pin number 4 is connected to pin number 1 of NOT gate IC. So pin number 1 is connected with wire, and we'll going to join this pin number 1, or we'll do the connection afterwards. Now we are taking a wire from pin number 2 of NOT gate IC, and we'll leave it as it is, or we are connecting this to pin number 16, that is J input. So we have taken a green wire from pin number 2 and it is connected to pin number 16. Now pin plus 5 volt VCC we are giving to pin number 14 of 7404 IC, and ground is connected to pin number 7 of 7404 IC. Means we have given supply for 7404. Now we'll do the connection for clock, pin number 1. So we are taking wire from pin number 1, that is black wire. We are taking this wire from pin number 1 and we are connecting it into the square waveform clock connection. Here connection is provided for square waveform clock. We have already adjusted our frequency to minimum. Now we'll do the connection for preset and clear, that is pin number 2 and 3. We are going to connect this to plus 5 volt VCC. So first we'll take wire from pin number 2, it is connected in pin number 3, that means short is given there, and from that short we are connecting it to the plus 5 volt, means we are providing plus 5 volt to preset and clear because it is active low. Now pin number 5 VCC connection we are doing for our flip-flop IC. So pin number 5 is connected to plus VCC. Then pin number 13 will make pin number 13 ground of flip-flop IC. So this is pin number 13 and we are connecting this to ground over here. So pin number 13 and pin number 5 is a supply connection for flip-flop IC. Now we'll connect outputs, that is pin number 15 to output. So this is pin number 15, we have connected this to output section. This is our Q, and pin number 14 is our Q bar, that is also output. So we are taking connection from pin number 14 and again it is going to connect into output, that is our Q bar. So connection is done like this. We have done same connection like our pin diagram. Now we'll see the output section. Now we'll observe the output of our D flip-flop. As we have studied in theory that whenever we give output at D input, the Q will also glow. Means if D input is high, then Q is equals to 1. Here we have not applied any input. Now we are applying input. So you can see here the output is passing to next Q, because it is taking a delay, because it is a delay flip-flop. Because the clock pulse is provided over here, is provided with the help of square waveform. You can see a square is given over here. We are not giving clock pulse like we have used before. We are giving a square waveform. Here we have set a frequency of our minimum frequency of our square wave signal. So you can see that we have provided a clock signal is in the square waveform. So we are giving a positive negative going trigger over here, and to we are taking or getting a next trigger from here, it will take a very large time. So we are observing that our output is jumping from previous states to current state. It is taking this much time, because here we have provided this much time period from one trigger from another trigger. So you will observe here, if I am giving one input over here, so we will observe the output that is jumping from Q bar to Q, and it is taking a long time duration. So we have proved that here we have given 0 output. So you can see again the output is jumping from Q bar to Q. It will take some time because of that square wave clock pulse. So it is giving low output after some time, means it is facing that delay and providing output after some time.